Hello everyone and welcome to the next installment of our SarahTech Enablement series. My name is Andrea Hall and I am the Customer Relationship Manager here at SarahTech and I'll be your host today. Presenting today we have Mehdi Razawan and he is an Applications Engineer here at SarahTech. He'll be teaching you a little bit about the Freeform Modeling using Realize Shape Tool. But first I wanted to tell you a little bit about the SarahTech Enablement series that we've had such great success with. We usually run about 30 to 45 minutes. We try to keep it closer to 30 minutes. The training is also always led by the subject matter experts here at SarahTech. We cover topics including FEMAP, NX, Solid Edge, Team Center, and much more. We're always open to your suggestions as well. Be sure to check out our website for dates and times in the coming months. They might change a little bit here and there over the summer months. Our goal for the SarahTech Enablement series is to help you get the most out of your software. And really, the main goal is to just share knowledge amongst each other and to build a community of users so that we can help empower each other. As always, this is an open forum, so we look forward to you participating in the training. If you have any questions or comments during the presentation, just type them into the chat box over to the right, and I will kindly interrupt Mehdi and let him know about your comments and questions. And with that, I'm going to pass it over to my friend Mehdi.
Good morning, everybody. My name is Mehdi Razawan. I'm an application engineer for SarahTech, and my duties generally involve designing and drafting parts in NX11 or doing some stress analysis using FEMAP. In today's enablement session, you'll learn some of the basics of freeform surfacing in NX11 using the Realize Shape tool. But before we begin with that, we'll have a brief discussion about the two families of modeling approaches that industrial designers and engineers use. And we do this so that we can understand why NX11's Realize Shape tool was developed and why it's useful for you. We'll then showcase the Realize Shape tool with its ease and functionality in two demonstrations. And to begin, I'd like to discuss by discussing differences between solid and surface modeling methods. Now, surface modeling is probably the most well-known method of designing, and it generally involves generating a shape or surface by starting with a 2D sketch on a plane. We call this form of modeling solid because the math allows these models to be watertight or solid. Now, you can continue to design on the part by cutting out or building on top of it because internal details of the product are included. As you may already know, each part of this model is added one step at a time until the complete model is finished. Essentially, these models are made by intersecting, joining, or subtracting objects from one another. So this is very useful for generating parts that are formed from planar surfaces such as a box or those that are rotated about an axis symmetrically such as a dome, because it's easy to go about making these parts from a 2D step-by-step method. It's a great way, an accurate way for 3D models to be built based on these 2D engineering drawings. Now, the other form of modeling is known as surface modeling, and this generally involves creating surfaces using splines. By drawing 3D curves in space with guidelines, we can create volumes in our CAD system by enclosing or following these curves. In other words, these surfaces are created and defined by the boundary of these curves. Now, why is surface modeling useful then? As compared to solid modeling? Well, if you're trying to develop consumer products or work in the automotive industry or develop recreational products, this is the modeling technique for you because there may be a lot of curves and surfaces that cannot be easily created using the conventional methods. Now, this is also important when aesthetics of a product are more important than the technical aspect, the planar surfaces, as you might say. Or maybe you're trying to reverse engineer something with organic geometry. Now, there's this form of surface modeling is developed using these curves, and this often is very time consuming. It takes a lot of time because it involves several steps in order to get the surface that you want. And since it's not step by step, such as in solid modeling or conventional modeling, one mistake can be very time consuming for you. Now, there's another form of surface modeling. This is known as freeform modeling, or known as a freeform method, and is generally used for concept design where aesthetics is a priority. It's very easy to make something such as a shampoo bottle or a deodorant container just by transferring a hand sketch that you made on a weekend and then showing that to your boss to see if it's viable. And this form of modeling is much easier because you don't have to go through the time-consuming task of creating the 3D curves with specific curvature that you want. However, it's not as precise, and you may not get the same characteristics of the part that you want. Now, today we're going to be focusing on the freeform aspect today because NX11 has this great tool called Realize Shape that allows you to do that. Now, NX Realize Shape might not be new to you guys. It's been available since NX9, but since then there have been great and significant changes to the Realize Shape tool that have made it much easier to use. So the way NX11's Realize Shape function is very similar to NX9 or NX10 in that it uses primitive shapes that you can then pull and push for the desired geometry. It's very quick to get to and intuitive to use, and on top of that it can also be used in conjunction with solid modeling. So here in this slide you can see that we go from a sphere and we stretch out that sphere to fit the mold of the housing that we see on the left, and then we unite that body with the body of the cylindrical head, and in the end you get a product of what appears to be a drill housing. Here's another example of the NX11 Realize Shape tool being used. We start with a block, and by pulling and pushing to the desired locations that we want, we're able to make a car mirror. So with that, I'd like to start our first demo, which will take a cylinder and change that into a flask using a few steps. So if you open up NX, we can go to the welcome opening bar and window, and if we click on new, before we click on new, you want to make sure that you're in the correct role. And we're starting with the default role, but I want to go to the advanced role. So click on that hammer and click on advanced. You can get to that. Click OK to move on to the next step. From there, you can click on new, and we'll start by opening up the new model. And you can save that anywhere you want. I'm going to save that to the desktop, and then press OK. From here, you have the standard NX bars and tools that are accessible to you. You want to click on the Surface tab available here, and then click on the NX Realize Shape icon to get to the environment. From there, you'll be opened up to a series of functions that you have access to. But before we do anything, we want to click on the Primitive Shape tool. That'll give us the base geometry that we need in order to push and pull. Now, this dialog window will open up, and you'll have the access to be able to change which shape that you want, or generate which shape that you want, and you have a series of shapes that are available to you. So you have a sphere, which we won't be using today, a cylinder, a block, a torus, and so on. We'll click on cylinder just to begin, and over here you'll have the size and height and segment numbers that you were able to change. Size refers to the size of the actual length of the box, not the radius of the cylinder or the diameter of the cylinder. So that might be a misconception that some people have. The height still refers to the height. So 6 inches by 7 inches sounds good, but I think we're going to change our cylinder to 3 inches. And let's change our height to 5. We have one segment, which is which defines how the cylinder is spaced and broken apart, how many nodes you have essentially. And we can raise that at any point. So if you do linear segments, you can add and it'll split up the cylinder equally in parts of however many lines that you've asked for. So obviously this cylinder right here has been cut up into 4, which means that they're spaced about they're spaced a quarter of the length each way. Now we're going to go back to 1 because we don't need that. And same thing with the circular. We can also change how many nodes of the circular face correspond to that plane. We're also going to keep that to 4. We can go down to 3 because that's the minimum for the cylinder. Anyway, press OK and we get to the cylinder that we want. This doesn't look like a flask yet, but you'll see pretty soon that it's quite easy to get there. We're going to click on the symmetric modeling switch that we have on the left right next to your finish button, and that allows me to model and stretch or pull symmetrically about whichever plane that I choose. I'm going to choose the XC plane, which you can choose right here, but you're not limited to that. You can choose any plane that you want, just as you would in solid modeling. So click on that and press OK. And we get this. It got split up into 2, and any changes that I make to this side will correspond to the next side. This is useful for a lot of tools where you need to, where each side is symmetric. We're going to then split the face of the cylinder so that we can cut up the cylinder intersections, and we're able to pull the flask into the shape that we want. I'm going to choose these 3 faces because I want to be cutting it horizontally, and I can click, once I click the faces that I want the lines to be on or the cuts to be on, I have to click on the select reference edge, and this edge is normal to the line that you select or the edge that you select. As you can see, you have these lines that come up to cut up the cylinder. You can move that up and down and position them in whichever direction position that you want. We're going to increase this to 4 and move this one down, maybe move this one in the middle a little bit, and move this one up. And then we're going to press OK. Now, let's say you mess up and you forget to add a split face. You can always go back and click on the split face function again and click on any 3 faces that you want and get to that point. In NX11 too, you still have the function of or the ability to click on whichever sections that you want, and also what type of face or edge that you want to select. You can click on single object if you're only interested in one. I try to really do loop though, just so everything is pretty clean. And so from there, we can then, if we get out of that, we can then go to the transform cage tool that allows to move these edges, nodes, or faces and pull or push or magnify in whichever direction that we want. I'm going to click on these 2 faces down here, as well as this one, and then I'm going to drag this arrow by clicking and holding it to push it out. That allows me to change the shape of the cylinder. Once I'm done, I can either click apply or OK, just like any other function in NX. I'm going to press apply because I still want to do more changes. And then I'm going to keep selecting faces. And then I'll drag this one so it's a little bit thinner. Maybe this looks good. That's okay. Now, this doesn't look like a flash because obviously this edge is coming out too far, but I can always move that edge as well. Click on the Transform Cage tool, click on the Type Filter, click on Cage Edge, select that edge, and then move that in whichever direction that I want. So that looks a lot better. And I can press OK. I can do the same thing with a series of edges as well. So if I click on these 3 edges and move it up, I'll get a little bit more of a stout end. And then I can do the same thing over here. Just by clicking and pulling everything, it's very intuitive. I never had to go to a sketch and create anything, and that's kind of the benefit of this tool. Now you'll notice here that the axis will follow the lines of the closest plane, but you can always change the directions that you want or the plane by going to the drag command tab right here and then moving it in whichever location orientation you want. You're also able to double click and change the angle to which it moves in any direction. So I want to move that up probably 45 degrees. So it's more planar. Oh, actually. But I can also drag that in any way I want as well. So if I click that again, click these 3 edges, click on the drag tab, move this, and then move that in here, transform that, and then drag it, I can get the shapes that I want. This looks like more of a vase, but I think you get the idea of the NX Realize Shape tool here. You can also split faces, which you can also subdivide faces, my mistake, which let's say I wanted to add a lip on this bottom edge. I can do that by changing the percentage, and I'm going to add that by just dragging and pulling to whatever percentage I want. Press OK. I'm going to make another subdivide face so that I can get that draft in that lip. So I'm going to press OK, and then I can move that face while clicking on the Transform tool. If it's hard for me to select that face, I can always go here, click on Cage Face for the selection filter, and then find that face that I'm looking for. Once I'm there, same things apply. I can just rotate around and then get to a point where I can see everything and then move that up. And then, voila, I have a lip on the bottom edge. I can also delete faces. Now keep in mind this is still a surfacing tool, so everything is a sheet. So once I delete a face, you'll see that it's hollow on the inside. So if I delete this, you'll notice that it's still hollow. Now, this is kind of the, we went from a flask to a vase, but it's very easy to go to any shape that you want. And at this point, I'm going to press Finish. And once I'm here, I can still use the same tools that were used in solid modeling techniques in NX. So I'm going to go here. I want to thicken this so that it actually is legitimate. And I can do that by clicking on this thicken function. I'm going to use a square tool to grab everything. And it's a little bit laggy, but thicken it by 0.2 of an inch. Press OK. Anyway, so you kind of get the idea here is that you can change these surfaces and then add changes that you want. I can also go back here, add a diagonal plane, and then cut into this if I want. So those are the kind of the cool things you can do. Let's say I made that mistake of cutting it and I didn't want to cut it. Well, I can always go here. I can sew this cage, click on these edges, and get to where I want. I can also bridge this face in a similar manner. Oh, whoops, forgot to click on the correct one. And yeah, we're running a little bit out of time on this one though, so I'm going to move on to the next demo. And we'll do that by opening up a new model. So same thing, open up a new model, and this time we're going to be making a seat using a sphere. So if we click on the surface, click NX Realize Shape tool, click on the primitive shape. And this time we're going to be using a sphere, so we click on sphere. We're going to make the sphere pretty large. Let's make it 6 inches and then press OK. Now I can drag this up by clicking all of the faces and then dragging up. And press OK. From here, I'm going to do a symmetric modeling again, clicking on this face, clicking on that XC plane that I've indicated from before, and press OK. I'm then going to drag this face so it pushes out a little bit more so I can get that head cushion look, and press OK. I'm then going to use the split face function and split these faces.
Hey, Mehdi, we actually have a question.
Yeah, go ahead.
Okay, so Jeff would like to know if you can show or talk about how the Realize shape would be used in a manufacturing application, such as boat design. Is that something that you're able to get into?
Yeah, definitely. Okay, so let's stop real quick and go back. Let's delete this and let's go. I'm going to make a very rough boat, or if you want to call it a boat. But a cool thing about NX Realize Shape too is that once I make a shape, I can then go to the analysis tool set in NX, and I can find things like how much volume does this enclose. So it might be useful in a boat application where you're concerned about maybe the buoyancy of a boat, or even the aesthetics. And if maybe the aesthetics of a boat don't look good and you want to play around with the volume just to make sure that everything fits, we can do that by going to sphere, click OK again, primitive shape. Try to be a little bit quicker on this run. Once I have that sphere, I can pull and push. So I'm going to pull that. Oh, as you can see, this one made two spheres. All right.
And I know you're doing your best here because we're on a little bit of a time constraint, but folks, if you would like to see any more of this in detail, we'd be happy to follow up with you after the webinar, but you're doing great. You're fine.
All right. No, thank you. So if I split this face and cut it up into a few more sides, click this reference edge here, maybe go like 2 or 3, do this on each side. And then drag those faces down. I might be able to get the shape of a very, very rudimentary boat. I don't know if you can see that, but it's, I need to move this up, so I'm going to click these edges, go to edge. Rotate the axis so I can get the right orientation that I want. Transform it and then move it up. Give me 1 second. You can always press Control Z2 to go back. I think I need to split this face up a couple more times. Okay. I go here, and then I click on the datum plane. Click on this top plane right here. Move it up a little bit more and extend it. I'm doing this very rough, so I'm trying to be quick, but I'm sure you could like make a much cleaner looking boat. If I click on extrude and make an ellipse, and then cut out this ellipse into the surface. I can get something like this. Now, obviously, this isn't like a good-looking boat, but I think you get the idea. Like, you can make a boat out of that, and then from there, if you're worried about buoyancy in space and those sorts of things, you can go to the analysis tool and click on Measure Body, and that would give you the volume of the space that you're taking in. And you can do this at the same time with spatial constraints. So let's say you make a surface on the inside right here, then you can find out, okay, how much room do I really have on the inside, you know, or those sorts of things.
Very nice.
You can also do,
Thank you.
You can also do reflection analysis. So just like any other tool, you can click on it. So maybe you want your boat to look really nice with no glares, or you're worried about some curvature and it's standing out and looking like a blemish or whatever, then you can go and do the reflection analysis, click on the number of lines and lights that you want, and then you can see, okay, like, you know, there's not that much, there's a few glares here and there.
Hey, Mehdi, it looks like they're a little confused as to, can you clarify when you need to use split face?
Oh, okay, yeah, no worries. Well, the split face function is used when you want to go and split. Let's say I'm starting out with just a face like this. If you want to split it up into the lines as shown here, then the only way to do that is to use a split face function. Let me hide this, and then I'll show you with a new primitive shape. So if I go here, surface, next realize shape, click on primitive shape, let's do a block. That's okay. Oh. Okay, so I got my block here. We can ignore this datum plane for now. If I want to split that cage into faces, the only way I can do that is like cutting it up. So maybe this is this what you mean, Jeff?
Well, he won't be able to speak up, but yeah, I think you went into lots of detail on that one. That's awesome. And I know you're trying to kind of get through this because we're on a little bit of a time constraint. I think some people did want to see a little bit more clarity. So please make sure that I see a couple of questions on here. So make sure at the end you're welcome to email us and we can go into a little more detail. I know Mehdi's doing the best that he can. But we should probably go ahead and start wrapping up here, and then we certainly don't mind doing some follow-up over the next couple of days and spending a little extra time with each of you if you need to see something else.
Yeah, I can definitely. I think for me it's more of a time constraint thing, just because there's a lot in this tool that is very powerful tool, and you can do a lot with it. Anyway, with that, I'd like to conclude the demos. And yeah, I think to summarize, I think I was able to give you guys a brief understanding of the freeform modeling and a very basic understanding of the NX11's real-life shape tools functionality. And we saw that in a few demonstrations. Thank you. Great job.
Great job. All right. Our next session is going to be Thursday, July 20th at 10 a.m. Pacific. So 1 o'clock Eastern. And it's going to be with Mark Anderson. And he's done a few CES sessions with us in the past. And he always has a really great turnout. I know people really enjoy watching him go through the software. And then next slide, we will be posting this on YouTube today. And we'll also be sending the link out to you. So please feel free to, share that link. And we will be, like I said, we'll have everything just posted right there on YouTube. So make sure that you subscribe to our channel, and that way you'll see anytime that we have something posted on there, any new videos and things like that. And please, like I said, don't forget to stick around just for about 30 seconds after we close out the webinar. Let us know how we did. If you have any additional questions or need any additional information, you can put that in there and we'll be happy to follow up with you as soon as possible. Okay, and I hope everyone has a wonderful day, and we will talk with you soon. Thank you.
Thank you.